This is question 10 from paper 1-2 from the June 2020 exams from Cambridge International Education. In the description below this video, you'll find a link to an image of this question so you can try it before looking at my solution. The question gives us an equation of a curve here. Y is equal to 54x minus 2x minus 7 to the power of 3. And they ask us a couple of questions about that, really all revolving around differentiating it and stationary points. So let's do it in order. Part A asks us to find dy dx. So dy dx is each term, there's two terms, here's one, here's another. We could expand this out into more terms, but it's going to be easier to do it this way. The first term, 54x, is easy, x to the power of 1. 1 times 54, x to the power of 0 is just 1. Okay, so now we have a chain rule. We have a minus here, we can do that separate if we want. To do a chain rule, we just pretend this guy is x. Pretend the whole thing is x, so we get 3 multiplied by this thing we're pretending with, minus 7 to the power of 2. We differentiate it as if it was normally x, but that's not quite right. We still have to differentiate what's inside it. So what's inside it, the derivative of that is just 2, and we multiply it by. We can clean this up a little bit. We get 54 minus 2 times 3 is 6, 2x minus 7 squared. Do not square this out. It's going to be much more useful having something factorized in this sort of way. They then ask us to get the second derivative. That's d squared y over dx squared, or just call it the second derivative. So we just differentiate the last thing we have here. Again, we have two terms. First term, the derivative of 54 is 0. The second term then, we have minus 6, and it's a chain rule again. 2 times this bracket, 2x minus 7 to the power of 1 this time, all multiplied by 2 again. Let's clean this up. This one we can clean up more. Let's multiply outside here. 2 times 2 is 4. 4 times 6 is 24, minus 24, times 2x minus 7. You can leave it like that. That'd be perfectly okay. Or you could multiply it out and get 48x. What do we have here? Plus 140 plus 6, plus 140 plus 28, which is 168. You leave it like that. Either of these are fine. I'd say this one might be more useful. Okay, so that's part A. But part B, they ask us to find the stationary points of this curve. Now we can do this without drawing any pictures. But something I probably should have done at the start maybe is, whenever I can, I try to draw a picture of the question I'm dealing with. And you might think, I don't know what this looks like, it looks very complicated. But the important thing to know for any polynomial, which is what this is basically what's the biggest x there. There's a single x here. There's a single x here, but it's going to get cubed. It's going to 2x times 2x times 2x. Because of this guy is going to happen. So we're going to end up with an x to the power of 3 at the end. Let me write this out like this. Y is of the order x cubed. You don't need to know that. But really, what I'm going to get out is, let me rub that out. We're going to end up with a plus x by a plus x by a plus x. We're going to end up with plus x cubed multiplied by a minus. So we're going to end up with minus x cubed, and probably some number here. In fact, it's going to be 8. It's going to be a minus 8. It doesn't really matter though. Some number. I'll call it a for the moment. And I don't really care what's after that, because this guy is going to be the biggest, most important. We can actually already draw these pictures here. Let me just double check it is a minus. It is. Okay. We can already draw these pictures. When x is really big, think 1,000. 1,000 times 1,000 times 1,000. It's really big. It's positive though. Times a minus. So it's negative. So this drawing will look something like this when x is really big. It will just get smaller and smaller and smaller. When x is really small, think minus 1,000. Minus 1,000 by a minus 1,000 by minus 1,000 by another minus number. That's 4 minuses. So we get plus. And we get some really big number. So somewhere over here. And in between, cubics look like this. This is just something we've learned. It has 2 humps, cubics. To the power of 4, have 3 humps. So I actually already know the shape of this question. So when they ask us for the stationary points, they're looking for these two guys here. These two guys here. In fact, this drawing is going to save me work in part C, although I'll show you the way they sort of wanted you to do it. Anyway, let's go on to part B. Find these two stationary points. Well, these stationary points are when dy dx equals 0. That's what these slopes are. So dy dx equals 0 just tells us 54 minus 6, 2x minus 7 squared is equal to 0. Let's move all this around. We get 2x minus 7 on its own. Let's see, we'd have to have taken away 54 on both sides, so that'll turn into a minus. We'd have to divide by minus 6 on both sides. And this cancels in, so 2x minus 7 squared is equal to, that's 9, isn't it? Plus 9. Two minuses make a plus when they divide. So let's get the square root of both sides, or what number multiplies by itself to get 9? It must be a minus 3. This guy here must equal minus 3. Sorry, it must equal plus or minus 3, I should say. Either plus or minus, I'm not sure which. So 2x must equal, let's add 7 to both sides. 7 plus or minus 3. X must equal 7 plus or minus 3 over 2. That gives us two answers. Let me write them over here. Let's see, 7 plus 3 first we'll do. X is equal to 7 plus 3 is 10. 10 divided by 2 is 5, or x is equal 7 minus 3 is 4 divided by 2, x equals 2. There are two answers for x. Do not stop. So many students stop at this point. They didn't ask you to find x. They asked you to find the stationary points. They want to know x and y. They want to know x and y. So you need to put these numbers back into this, up here, y equals, because we know what y equals. Y is equal 54 multiplied by 5 minus, I'm going to run out of room here, minus 2x minus, not x, 2 times 5 minus 7 all to the power of 3. That's fairly complicated, but you put that into a calculator. You could do it in your head maybe. 2 times 3 is 10. 10 minus 7 is 3. 3 to the power of 3 is 27. This here is 270. 270 minus 27 is equal to 243. So that's 1 point. 5, 2, 4, 3. And you do the same with 2. You simply put 2 in instead of 5 here. 54 times 2. 2 times 2 minus 7. And the answer comes out, I did it earlier, 135. So the other answer will get 2135. There are your 2 points on this. Now I actually have enough room to answer part C. Part C, this picture tells me the answer to part C. I could simply say that this is the minimum and this is the maximum. Because look at the picture. The first number we hit is the minimum. So this one must be 2, because this is the x-axis. And this one must have been the 5. So that one must have been the minimum, that one must have been the maximum. After writing this, if you tell them because of the picture, that would be full marks. That's not what they want you to do though, so let me rub that out. Let me just show you, in case you're worried, what they want you to do is use this line here. They want you to show that d squared y dx squared is equal to, when x equals 5, is equal, put 5 in here, we get about 200, 190, minus 190, wait, that can't be right, no, sorry, minus 250, minus 240, plus that, I have the answer here. You would get minus 72, therefore that's a maximum. And on this guy, if you put the same thing in, you would get, if you put 2 into this here, you would get plus 72. 72 is bigger than 0, so therefore that's a minimum. Because that's the rule. If the second derivative is bigger than 0, like here, we have a minimum. If it's less than 0, like here, we have a maximum. It's another way to do that. But that's either way, that's your full marks for that question. If you have any questions, anything you want me to clarify, let me know in the comments and I'll do my best to get back to you. Have a great day.